This lesson is on plane curves and parametric equations. Parametric equations has two objectives. The first objective is the equation is based on time. That's where the t comes from. The second objective is convert these two equations into one equation. So one more time, parametric equation has two objectives. One, it is based on time. That's where the t comes from. T stands for time. The second objective is to convert these two equations into one equation. Okay? So find the rectangular equations of these two equations. So I'm giving you two options. It doesn't matter which one you use, it will be the same answer. So option number one, I'm going to solve for t in x. So I'm going to solve for t in x. So here's my x, solve for t. Bring the 3 over, plus 3. Now plus the t into y equation. Here's my equation for y. Take this equation, plug it into the t. Replace the t by this equation. So here's my y, 2. Remember, this was t. So plug t in, which is x plus 3 plus 4. Do your algebra. 2 times x is 2x. 2 times 3 is 6. Don't forget the 4. 6 plus 4 is 10. And whatever you need to combine like terms, reduce it if you can. This is the equation. Okay, so one more time. Parametric equation has two objectives. First objective is it is based on time. Everything is based on time. That's why it's called parametric, because it's based on time. The second objective is to convert these two equations into a single equation. So this equation is the same as this equation. One more time. This equation is the same as this equation. It's just written differently. This equation, we know what this is. This is a linear, a line. This equation is also a line, but based on time. Based on time. At time 0, when will x be? At time 0, when will y be? Okay, so that's what parametric equation is. One more time. Parametric equations, the first objective is on time, based on time. That's the first objective. Everything is based on time. The second objective is convert these two equations into a single equation. Convert these two into a single equation. This equation and these two equations are the same graph. Okay, the same graph. The only difference is that this doesn't have time, this does. Okay, so at time 0, at 0 second, when will x be? Where will x be? At time 0, where will y be? Okay, so that's what parametric is. Now I use option 1, so now let's do option 2, just the reverse of it. So in option 1, we solve t for x in x. So do the same thing, but now do for y. So solve t in y. So here's y. Bring the 4 over, minus 4, divide by 2. So take this t, plug into x equation. So here's my x equal t minus 3. So this right here was a t. This right here was a t. So plug the t in. Okay, don't forget the minus 3. Now I have a denominator. To get rid of the denominator, multiply by that number. Whatever that number is, multiply by that number to whole equation. So 2 times over here, 2 times the whole equation over here on the right. So whatever the denominator is, multiply to the left and the right. So 2 times x, 2 times this over here, the 2 disappears, so I just have y minus 4. 2 times 3, negative 6. Okay, combine like terms, rearranging the equations, and as you can see, it is still the same equation. It is the same equation. Okay, so it doesn't matter if I use option 1 or option 2, it is the same equation. Okay, so you pick. either 1 or 2. It is the same equation. One more time. What is parametric equation means? It means two things. One, it based on time, whatever time it is. Okay? And the second objective is convert these two equations into one equation. Okay? This equation is the same as these two equations. Same graph. One more time. These two equations and this equation have the same graph. It's just written differently. One more time. These two equations right here, these two equations, it is the same graph as this equation. It's just written differently. This is written on based on time. This is just based on x and y. Okay, so that's what parametric equation is. It is based on time. Okay, here's the next example. Here we have x equal to et, y equal 1 plus et. Note, if you remember, in natural log times e will always be 1. E to the natural log is also 1. So make a note of this. Okay, so again, it doesn't matter which option you use. What I have over here, it doesn't matter. Just pick one of them. Okay, so I'm gonna do for y. Okay, I'm gonna do for y. So here we go. First of all, bring the 1 over, so y minus 1. I want to get rid of this e, so multiply by ln to the left and also to the right. One more time, bring the 1 over, minus 1. I want to get rid of this e, so multiply natural log to the left and to the right. Why? Because of this note, I can get rid of them. So natural log y minus 1, leave it alone. Natural log e, well, natural log e is what? 1. So it disappeared, so I have t left. Now take this t, plug it into this t. Take this equation, plug it into this right here. So bring down this equation, so x equal 2e. Now instead of writing t again, you will write in natural log y minus 1. Well, e to the natural log, what was the rule? E to the natural log is 1. So that disappeared. So drop down the y minus 1. 2 times y is 2y. 2 times negative 1 is negative 2. And then after that, you just rearrange the equations. Okay, just rearrange the equations. Bring the negative 2 over, become plus. Divide by 2, which is this. Or you can write it like this if you want. Okay, so this two equations is converted into this equation, or you can write it like this if you want. It's the same thing. Again, parametric equation has two objectives. First objective, the equations that was given to you is based on time. The second objective is to convert these two equations into one equation. Okay, so that's the second example. Okay, here's the third example. Here we have x equals secant t, y equal tangent t. Okay, so first thing we need to do is rewrite this in trig ratio identities. We know that secant is 1 over cos. We know that tangent is sine over cos. Okay, well, let's solve this so that cos can be by itself. So just move them around. So move cos to the left, bring x down. Move cos to the left, bring x down. So we know that cos t is 1 over x. Okay, same thing over here. You're just moving things around. Bring the cos t over to the left and leave sine t by itself. Okay, leave sine t by itself. So in this part on the right, we want sine to be by itself. On the left, we want cos to be by itself. Well, what do you know about cos? What do you know about cos? Cos over here is 1 over x. So just replace it. Cos, we know that cos is 1 over x. So just replace it. 1 over x. Okay? And rewrite it as y over x. Okay? So again, on the left, we want cos to be by itself. On the right side, we want sine to be by itself. And here's the reason, so that we can use cos square plus sine square equal 1. If you remember, this is another Pythagorean trig identity. Cos square plus sine square is equal to 1. Well, we know what cos is, just plug it in, 1 over x. We know what sine is, y over x. Okay? And then do your algebra. So 1 over x squared is just 1 over x squared. Yx squared will be y squared over x squared equal 1. Okay? Now we want to get rid of these denominators. Just get rid of these denominators. So multiply by the same denominator. Okay? Multiply by the same denominator to the whole equations. So that's where I got the x squared from. X squared times this disappeared. So I just have 1. X squared times over here also disappeared here. So I have y squared. X squared times 1 is just x squared. Now I want the y to be by the number 1 to be by itself. So bring the y over, so it becomes negative y squared. So 1 equal x squared y squared is the answer to these two equations when you convert it. Okay, so one more time. When you have this, make sure use the ratio identity. Make sure that x with x, cos has to be by itself. With y, sine has to be by itself. So remember the trig ratio. One more time. X, if you have x, cos must be by itself. If you have y, sine must be by itself. Always use this equation, cos squared plus sine squared equal 1. Replace what cos is, replace what sine is, and then do your algebra. Get me square, y squared, x squared. Get rid of the denominator by multiplying the denominator. So this x squared disappears, I have 1. This x squared disappears, so I have y squared. X squared times 1 is just x squared. And then I want 1, the number 1, to be by itself, so bring the y squared over. So this is the answer to this equation. Okay, so one more time. These two equations right here, these two equations is the same graph with this equation. It's just written differently. So this and this two are the same graph, just written differently. These two are written in parametric equations. This is just regular rectangular equation. Okay, so it's the same graph. Okay, so be very careful on how to do the homework for this.